Around 50 meters to the foot of the building, the angle of elevation to the top of the building is found to be 60 degrees. Find the height of the building. So in this problem, we have a building, and 50 meters away from the foot of the building, the angle of elevation to the top of the building is found to be 60 degrees. So what we are going to find is the height of the building. So as you can see, the figure forms a right triangle. So for easier identification in our solution later on, we are going to label the edges as A, B, and C. So in problems like this, we use the trigonometric functions, which are the sine, cosine, and tangent theta. And we have a simpler mnemonic for that, which is the SOHCAHTOA. And this SOHCAHTOA stands for sine theta is equals to opposite over hypotenuse, cosine theta is equals to adjacent over hypotenuse, and tangent theta is equals to opposite over adjacent. So we will know when and how to use these functions depending on the angle, the given, and the thing that we are looking for. So in this problem, our angle is 60 degrees. And the height of the building, which is side AB, is the opposite of our angle. And our given 50 meters, which is side BC, is the adjacent side of our angle. So the function we are going to use is tangent theta, because it includes both the opposite and adjacent sides. So to the solution, we use tangent theta, and we are going to substitute theta by 60 degrees, since that is our angle, and our opposite angle is, our opposite side is side AB, while our adjacent side is side BC. And we know that the value of side BC is 50 meters, so we're going to substitute that in our equation. Now, in this situation, we are allowed to cross multiply what's on the right side of the equation to the left side of the equation. Assuming you know how that goes, we are going to get 50 tangent 60 is equals to side AB. So you input that into your calculator, you are going to get 50 square root of 3. And the approximation value of square root of 3 is 1.732. So in the calculator, if you input this, you're going to get directly the answer. But for others who don't have a calculator, I got the approximation of square root of 3, which is 1.732. Now you multiply that by 50, you're going to get a value of 86.6. So the height of the building is 86.6 meters. A ladder is placed against a wall such that it reaches the top of the wall of height 9 meters. And the ladder is inclined at an angle of 60 degrees. Find how far the ladder is from the foot of the wall. So in a wall measured 9 meters high, a ladder is inclined at an angle of 60 degrees. So when we say inclined, it means that it is leaning. So the ladder is leaning to the wall, and it makes an angle of 60 degrees. So what we are going to find is how far the ladder is from the foot of the wall. So as usual, we're going to label the edges of the triangle as A, B, and C. So in this problem, we have an angle of 60 degrees. And what we are looking for is side BC, which is the adjacent of our angle. And our given 9 meters is side AB, which is the opposite of our angle. So the function that we are going to use is tangent theta, which is opposite over adjacent. Next is substitute 60 degrees by theta substitute the theta by 60 degrees, and our opposite side is AB and adjacent side is BC. So this time what we are looking for is the adjacent side. So the value of the opposite side is 9 meters, so we input that in our equation. Next, we cross multiply that as well. So we're going to get the equation BC tan 60 equals to 9. Since we can input this directly into our calculator, we are going to isolate the BC, the side BC, since this is what we are looking for. So what we are going to do is we divide both sides of the equation by tan 60, which will leave us with BC equals 9 over tan 60. So if we input that in our calculator, we are going to get a direct answer. But for those who want to know how it goes, I will explain it specifically. Next, we're going to get 9 over square root of 3, since the value of tan 60 is square root of 3. Now, what we're going to do here is we need to get rid of the radical in the denominator, since we can't have that. So to do that, you have to multiply the numerator and the denominator by the radical. Multiply that, we are going to get 9 square root of 3 over 3. Now, simplify that, we are going to get 3 square root of 3. The approximate value of square root of 3 is 1.732. Multiply that by 3, we are going to get the value of 5.2. So the distance between the wall and the foot of the ladder is 5.2 meters. A string of a kite is 80 meters long, and the inclination of the string with the ground is 45 degrees. Find the height of the kite, assuming that there is no slack in the string. So in this problem, we have a kite, and it has an 80 meters long string, which is inclined to the ground by 45 degrees. So the thing that we are looking for is the height of the kite. How far is the kite from the ground? Now, in this figure right here, our angle is 45 degrees, and the opposite side of that is what we are looking for, the height of the kite. And our given 80 meters is the hypotenuse of this triangle. So this time, the function that we are going to use is sine theta, because it includes the opposite side and the hypotenuse side. As usual, substitute theta by 45 degrees. Our opposite side is side AB, and hypotenuse is side AC. Substitute the value of side AC, which is 80 meters. Now, cross-multiply this as usual. Cross-multiply the right side of the equation to the left side of the equation. We're going to get 80 sine 45 equals AB. Now, in some calculator, if you input this, it's going to give you a direct answer. But for some calculator like mine, it's going to give you 40 square root of 2. And so you get the approximate value of square root of 2, which is 1.414. Multiply that by 40, we are going to get 56.56. Round that up to the nearest tens, we're going to have the value of 56.6. So the height of the kite from the ground is 56.6 meters. A ladder leaning against a vertical wall makes an angle of 30 degrees with the ground. The foot of the ladder is 3 meters from the wall. Find the length of the ladder. So in a wall, we have a leaning ladder, which makes an angle of 30 degrees. And the distance between the ladder, the foot of the ladder, and the wall is said to be 3 meters. And so what we are looking for is the length of the ladder. So in this figure, our angle is 30 degrees, and our given 3 meters is the adjacent side of our angle. And what we're looking for, which is the length of the ladder, is the hypotenuse. So in this problem, in this solution, the function that we are going to use is cosine theta, because it includes both the adjacent, which is our given, and the hypotenuse, which is what we are looking for. Substitute theta by 30 degrees, and our adjacent side is side base BC, and our hypotenuse is side AC. Now, we know that the value of our adjacent side is 3 meters, so we're going to input that in our equation. Cross multiply this, we're going to get AC cosine 30 equals 3. Now, since we can't input this in our calculator, because our calculator won't give a direct answer, we're going to isolate AC, because this is what we're looking for. Since AC is what we're looking for, we're going to isolate that. And in order to do that, we're going to divide both sides of the equation by cosine 30. With that, we're going to get AC equals 3 over cosine 30. Now, if you input this, again, if you input this in your calculator, you're going to get a direct answer. But I'm going to simply explain it specifically in here so that you can understand better. Now, the value of cosine 30 is square root of 3 over 2. So what we're going to do in this part is cross multiply the numerator by the denominator, since the denominator is a fraction. So we get the reciprocal of that. We're going to get 2 square root of 3, and we're going to multiply that by 3 over 1. You can put over 1. You can put a denominator of 1 in here, but if you do not, it's fine. It's the same. I just put it like that so that you can understand better. Now, multiply that, we're going to have 6 over square root of 3. Now, as I have said earlier, we can't have a fraction with a radical denominator. In the previous problem, I multiplied both the numerator and the denominator by the radical. However, in problems like this, we are allowed to get the approximate value of our radicals. So we can either get the approximate value or multiply the numerator and the denominator by the radical. It's fine. Whatever method you use, it's gonna get you the same answer. So this time I got the approximation value of square root of 3, which is 1.732. Divide 6 by that, we're going to get 3.46. So we round that up to the nearest tens, we got 3.5. So the length of the ladder is 3.5 meters. From the house's second floor window, Ted sees his dog on the ground. The angle of depression of the dog is 40 degrees. Ted's eye level is 28 feet above the ground. How many feet must the dog walk to reach the open door directly below Ted? So in the first 4 problems that we tackled was associated about the angle of elevation, which means that the object or the point of view is on the ground. However, in this final problem, we are associated with the angle of depression, which means that the object or the point of view is up above. So the solution, in terms of solution and the angle of depression and the angle of elevation, they are entirely the same. And the angle of depression, we only have an additional calculation, a simple calculation, but aside from that, the solution of both things, angle of depression and the angle of elevation, is entirely identical, entirely the same. So in this problem, we have a 2-story house and a dog. Ted is situated on the second floor window, and on that window, he sees his dog. And the angle of depression of the dog is 40 degrees. Ted's eye level is 28 feet above the ground, which means the height is 28 feet. So what we are looking for is the distance between the dog and the place directly below Ted. So, in order to use the trigonometric functions, we need to use an angle inside the triangle. However, 40 degrees isn't inside this said triangle. So what should we do in order to find the angle inside this triangle? So as you can notice, these two angles that we're talking about, the 40-degree angles and this angle inside the triangle, forms a right angle. And the measure of a right angle is exactly 90 degrees. So in order to find the value of the angle right here, we simply need to subtract 90 degrees by 40 degrees. So you subtract that, we're going to get the value of 50 degrees. Now, we can use the trigonometric functions. So in our angle right here, this 28 feet given is the adjacent of our angle. And this distance that we are looking for is the opposite side of our angle. So in our solution, the function that we are going to use is tangent theta, which is opposite over adjacent. So the theta, we're going to substitute that by 50. We're going to use the 50 degrees, not the 40, since 50 degrees is what's inside the triangle. And our opposite side is side BC, and our adjacent side is side AB. Now we substitute the value of side AB, which is 28 feet. Cross multiply that equation, we're going to get 28 tan 50 equals BC. Now, input this into your calculator. You are going to get the value of 33.4. So the distance the dog must walk to reach the door directly below Ted is 33.4 feet.